Yeah, hello. Welcome everyone. Yeah, thanks for the confirmation. So, how are you? Okay, thanks, Ravi. Yeah, okay. Yeah, I am Jagrati, host of today's session, and today we are going to cover how CP help to crack Google interview. Plus, we are going to cover one topic, Sieve. So, please stay tuned to the end of this session. Okay. So, let me welcome Ivan Deka to this session. Yeah, thank you. If you have any doubt, you can fill the form which given in the chat box. So we will answer later, and you can post your query in the chat box. So Ivan will on, during the live session. Okay. So yeah. Hello, Ivan.
Hi everyone,
Yeah.
hi Jagriti.
Hi. How are you, Ivan?
Yeah, it's been fine so far. Am I audible? Like my voice? Like my voice is okay, right?
Yes, your voice is too good. So, Ivan, could you please inform me? Could you share your intro a little bit?
Okay, so hi everyone, myself Ivan Deka. I am currently a software engineer at Google. Like I just recently joined only. Like I am a graduate from IIT Bhilai. My degree was in electrical engineering. And during last year, I was also an intern at Google. So yeah, like I kind of got a PPO from there only. And if I talk a bit about my coding journey, especially competitive programming, I was active in competitive programming during my second and third year. Like if I talk about the maximum ratings that I achieved, like it was candidate master on code forces and 5-star on CodeSafe. So yeah, like that was kind of a brief and a basic intro from my end.
Thanks, Ivan. So, anyone has a doubt or anyone has a query? Okay, Ivan, so you can continue the topics live for today. Later, we will clear their doubt if they have any. And you can post your doubt in the chat box. We will pick your doubt one by one later. Okay?
Okay, then shall I share my screen?
Yeah, you can.
Okay, give me some time. Share screen. Can you confirm whether my screen is visible?
Yes, Ivan.
Okay. Okay. My whiteboard is visible, right? Can you please confirm once? Okay. Okay. Thanks a lot. Okay. So, like the topic that we will be briefly going through for today is a seed. Like I assume, like many of you might have heard about the topic, or like many of you might also know some bit about it. But today we will try to go through a little bit in depth to understand how, like, what basically Sieve is and how we can actually use it, like how to implement it during our problem solvings, and we will also try to figure out why Sieve becomes beneficial and like what the traditional, like Sieve is a technique, right? So maybe some traditional techniques like what are the advantages of using Sieve over them? Okay, so oh, I'm so sorry. From mine, my screen just kind of got disconnected. Yeah, I think the issue is gone. So let me continue. Can someone confirm on the chat whether my screen is now being shared or not? Just give me some time. Sorry, guys, from my end. Okay, I think now it is shared. Can anyone confirm the chat box? Okay, thanks a lot. So, what I was telling was today we will just try to go a little bit in depth about shift and try to figure out why this particular technique is very useful in certain problems, which has certain restrictions on them. So before going ahead with shift, I will assume that everyone here have a basic understanding of what are prime numbers, what are composite numbers, and then if I ask you like what is a prime factorization or divisors of a number, you guys kind of know like what are divisors of a particular number. For instance, if say take the example of a number 36, its divisors will be 1, 2, 3, 4, 6, then 12, then 18, and then 36. I guess I hope I am not missing anything. And for 36 again, if I say what is its prime factorization, then it will be 2, 2, and 3, 3, right? So like this will be prime factorization of 36, and these are the divisors of 36. Okay, let's go ahead. Now, for very, if I tell you, if I give you a number n and ask you whether n is prime or not, whether it's prime or not. Like the very basic approach, like the very brute force approach is obviously like we can run a loop from let's say 2 up till n, and up till we reach n minus 1, and we can check if any of the numbers divides n, then we can say that like if this condition becomes true, then it is not prime, right? And again we can optimize this in this case, though we are going up till n minus 1, but eventually like we know, right, we don't need to go so far. If we run our for loop from I equals to 2 up till I star I less than equals to n I plus plus, if we run this particular for loop and check whether if any of the i's divide n or not, and if it comes out so, then it is obviously not prime. Else we can say that n is a prime number. Else n will be a prime number. Okay, like these are the very basic things. I hope that like most of you are already familiar with it. So I'm not going in very much depth in this thing. So now, and by looking at this following approach, one can also say that to check whether n is prime or not, to check whether n is prime or not, the time complexity that we are investing comes out around root n, right? Because here we are, the loop is going up till I square less than equals to n, which is equivalent to saying I less than square root of n. So one can tell, like one can looking at the loop can tell me that okay, if we use this particular for loop to find out whether n is prime or not, the time complexity will be square root of n. Okay, now let me kind of take this question to the next level. So now, if I tell you you are given a number n, and then from 1 up till n, you need to tell me which are the prime numbers. Like from 1 up till n, you need to print out which are the given prime numbers. So, like as I have already said that like this loop can figure out whether a particular number is prime or not. So you guys will say that okay, why not just run a loop from 1 I less than n I plus plus, and then use the check prime. This check prime function is nothing but the for loop above. So you guys can again argue that okay, like if we need to find only prime numbers from a range, let's say from 1 to n, we can do it, right? Like we already know whether to check how to check whether a given number is prime or not, and we can just simply add another, like we can have a nested loop, and in that way we can easily figure out which are the prime numbers in a certain range. And I will say okay, it looks good. Now again, looking at this above nested for loop, one can also tell me the time complexity, right? Like I can can you guys just write on the chat like what the time complexity of this particular nested for loop will be? Okay. Saurav has already answered. And to the power 3 by 2, you mean n, I guess you are saying n square root of n. Okay. Okay. Lalit, you were saying I can only, like I said, for this entire nested loop, say, like the loop starts here, right? Like the loop, this is the for like the loop has started here and it is calling the check prime function. And I have said the check prime function is nothing but this loop above, which checks whether the given particular number is prime or not. So it becomes a nested loop, right? Like this particular check prime function is this particular loop only, in which we are trying to figure out whether the given number is prime or not. Does it answer your doubt? Okay, if some guys are saying n square, but like this particular loop is going up till root n, and this particular loop is going up till n, so the time complexity will be n root n, right? Okay, okay. So like pretty much everyone kind of have got the grasp of how can we can do this. But here I will then ask you, like since the time complexity is coming in n root n, what can be the maximum value of n that we can kind of have here, so that our kind of loop, like our programs get executed under 1 second. in 1 second, like what can be the maximum value of n we can compute? Any ideas? Like what can be sorry, my max isn't clear. What can be the maximum value of n that we can use here, like in order to compute under 1 second? Like in 1 second, let me give you a suggestion. Like we can run up till 10 to the power 8 operations. Like it depends on the online judges you are using, but we can safely say that in 1 second we can run about 10 to the power 8 operations. Any guesses in the chat box? Okay, some guys are saying 10 to the power 4, some guys are saying 10 to the power 5. Okay, if we put, let's say, n is equal to 10 to the power 5, then what will be n root n? So it will be 10 to the power 5 into square root of 10 to the power 5. So it will be 10 to the power 5 into 10 square into root 10, and I guess root 10 will have some value around 3, so we can say that it comes around, like it will all about, like it is, like it will almost come around, let's say 3 point something, root 10, I guess 3 point, so let's say it's 3, only 300%, so that's okay. So like 10 to the power 5 will run. We can safely assume that for n here, we can at, like we can at most take our n to be in the range of 10 to the power 5. But now if I say that what if I want n to be more than 10 to the power 5? So let's say if I take n to be at 10 to the power 6 or 10 to the power 7, this above method will give me TLE, right? Like you can put the value of n here as 10 to the power 6 or 10 to the power 7, and you will realize that the final evaluation comes more than 10 to the power 8. So like here just now we have hit a limitation, right? That if we use the method that we have just shown here to find all the prime numbers from in a given range from 1 to n, we can only use it up till n in the range of 10 to the power 5. We cannot go beyond up till 10 to the power 6 or 10 to the power 7. So this is where sieve as a technique comes into picture. Okay, so now let's start our discussion about sieve. Let me just write it again. For we just change the paint color. Sieve. Okay, so uh, rather than explaining sieve theoretically, I will try to explain it using an example so that it becomes easier to grasp. So let me pen down few numbers. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. I guess these many numbers would suffice. Okay, someone is asking why its name is Sieve. Like I don't know why the technique name is Sieve. You can look up. Okay, so I have these many numbers in here. So what I'm gonna do now is that, like initially I have marked initially all the numbers I have marked as unvisited. Like the moment I visit a particular number, I will cross it with a red color. So currently, you can assume that I have an array of 30 numbers or anything like that, and you can safely assume that all the numbers are unvisited. What I will do is, I will go in this direction, and the moment I find a unvisited node, I will then again go beyond and mark down all the numbers that this particular number divides as visited. Like I will, and then I will also have a particular set which I will name as prime set. That in this prime set, the moment I visit an unvisited number, when I'm going ahead, I will put that number in this prime set. So for starters, one we already know is a prime number. So before starting our journey only, we will mark one as visited, in the sense that we are telling that one is not a prime number. Okay. Now from one we move ahead up till two. So now we have reached two. Now when we reach two, we see that okay, two isn't visited yet. So we put two here in our prime set. Now, starting from 2, we again start a journey in which we mark all the numbers which 2 divides. So, for 2, it divides 4. Okay, we mark it as visited. It divides 6. Okay, it's visited. It's divide 8. It divides 10. It divides 12. It divides 14. It divides 16. It divides 18. It divides 20. It divides 22. It divides 24. It divides 26. It divides 28. It divides 30. So, we have marked down all the numbers that are divisible by 2. Okay, now we again go ahead in our loop. Now we have reached 3. Now again we see that 3 isn't visited yet, so we put 3 in our prime set. Now from 3 you can consider we can start another loop, and we will just go ahead and mark down all the numbers that 3 divides. So okay, 3 divides 6, so it's already done. 3 divides 9, okay, we mark it. 3 divides 12, we have already marked. 3 divides 15, so we marked it. 3 divides 18, but it's already marked. 3 divides 21, okay, so we marked it. 3 divides 24, but it's already marked. 3 divides 27, so we mark it. And 3 divides 30, which is already marked. Okay, now so far it's done. Now we go move ahead to 4. Now the moment we reach 4, we realize that okay, 4 is a number that has been already been visited. Like the number has been already marked. So the moment we reach a number which is already marked, we don't do anything. We neither put it in a prime in our prime set, nor do we go ahead and mark the number it divides. So since 4 is visited, we do nothing and we go ahead in our loop. Okay, now we have reached 5. Now we see that 5 isn't marked, so we put 5 in our prime set. And for 5, we again do the same thing. We go ahead and mark down all the numbers that 5 divides. So 5 divides 10, mark. 5 divides 15, it's marked. 5 divides 20, it's marked. 5 divides then 25, let's mark it. Then 5 divides 30, it's already marked. So okay, then let's move ahead. Now we reach 6. We see that okay, 6 has been already marked, so we don't have to do anything, and we go ahead. Now we reach 7. We see that 7 isn't marked, so we firstly put 7 in our prime set. Then we will go ahead and mark down all the divisors, all the numbers that 7 divides. So 7 divides 14, it's marked. 7 divides 21, it's already marked. And since 7 divides 28, but it's marked. Okay, so for 7, it's done. Now we reach 8. We don't have to do anything since it's marked. Then we reach 9, we don't have to do anything. Then we reach 10, we don't have to do anything. Now we have reached 11. So the moment we reach 11, it's all unmarked, so we put it here firstly. Then we mark down all its divisors. So 11 is 22, it's marked, so we don't have to do anything. Now let's move ahead. We reach 12, it's marked, so we don't have to do anything. We reach 13, it isn't marked, so firstly we will put it in our set and try to see if there are any divisors of 13, any numbers that 13 divide. So 13 divides 26, but it's already marked, so we don't have to do anything. Then for 14, again it's marked, so we don't do anything. 15 it's marked. 16 it's marked. We reach 17. 17 isn't marked, so firstly let's put 17 here. Then for 17 we check out are there any numbers that 17 divides. Okay, there aren't any, so we move ahead. We reach 18, it's marked, nothing to do. We reach 19. Okay, 19 we put it in the set. We put it in our prime set, and there aren't anything, so we move ahead. 20 is marked, so we don't have to do anything. 21 is marked, same as 22 is marked. We reach 23 isn't marked, so we put 23 here. Now let's go ahead. 24 is marked, 25 is marked, 26 is again marked, 27 is already again marked, 28 is again marked. Now we reach 29, which isn't marked, so we put 29 here, and then we 30. Now you can see that if by doing this particular technique, I just got all the prime numbers in the range from 1 to 30. Like if you look at this particular set that I have here, it consists of all the numbers which are prime and which lies within the range of 1 to 30. So like currently here I just chose 30 numbers, but I can actually scale this particular technique beyond like up till any particular n, right? Like though I choose n30 here, but I can scale this technique to a much larger n. And like this particular technique will give us the prime numbers between for that particular range. Now one might ask that, okay, like how can I be sure that all the numbers here that come inside the prime set are like prime only? Like can there be a situation in which the a number that enters our particular set may not be prime? So I will say in that case no, that cannot be possible, because the very basic terminology that we are using during the application of this technique is that the moment we find a unvisited number, and in we take that number in our prime set and we then mark down all the divisors. So there is no way a composite number can enter this particular set, because a composite number which will obviously be divisible by some prime number, right? And that prime number will automatically mark that number down the moment we kind of find reach that prime number in our loop. So like this is the very basic idea behind the technique of sieve. Do If you have anything to ask regarding this particular technique, you can write on the chat box now. Yeah, like Neeraj has said, just jump to all multiples of a number using a loop. Like that was what I was doing, right? Like when I say I'm marking down all the numbers that are divisible by the particular number, I'm eventually just jumping through the multiples only. Okay, one is asking space complexity is of n. I think when I will be writing the code, you can safely assume, yeah, like space. I like we have a markdown array, and we can again have a prime array. So in both the cases, space will be linear only. So yeah, we can safely say space complexity is O of n. Okay, no one is asking what can be the maximum value of n. Like when we'll discuss the time complexity for this particular solution, I will go through that, like what can be the maximum value of n, and like the maximum value of n, to figure out what the maximum value of n is for the solution is very important, because if that number is isn't significantly large enough compared to 10 to the power 5, then why even we need to use it, right? So like yeah, I will go through that when will be discussing the time complexity. Okay, someone is asking, can Google ask hard questions more than easy and medium? It depends on the interviewer, right? Okay, okay. Now let me just go write this pseudo. Like let me just write the pseudo code here. Later we can write down using our editor. So what I'm doing is I will have a visited array. Let's say I'm given a number n, and I have a visited array where I initialize everything as zero. Zero in a sense like everything is unvisited. Then I will also have my prime, vector prime. Sorry, let me have a vector prime. So vector after prime. And what we can do is we can make our first node as visited because we know that it is not a prime number. So let me now start the for loop. Okay, so we are starting from 2. Let me first go up till n. Go. So now first thing I need to check whether the particular number is visited or not. So if this particular number is visited, so if it is unvisited, so if my number is yet to be visited, then what I will do is first I will put it inside my prime set. So prime dot, after putting it in my prime set, I will again start a loop going through all its multiples, and I will mark those particular numbers as visited. So visited of j equals to 1. Okay, so this will be the very basic pseudo code. So now, okay, so okay, so this is the very basic pseudo code of what I just discussed. Now let us try to think, is there ways that we can even optimize this particular code only. So the first thing that is coming to my mind is here, in order to go over the multiples of a particular number, I am starting from j equals to 2 into I. Here, rather than starting from 2 into I, should I start from j equals to I into I? Any thoughts on the comment section? Like, can I start from j equals to I into I rather than 2 into I? Like the basic, very basic motive firstly was to obviously go over the multiples of the given prime number, but is it necessary that I need to start from 2 into I, or can I just start from I into I? Any, if anything comes to your mind, you can write on the comment section. Any intuitions, or whether can we use it from I into I, not 2 into I or any other number? Okay, someone is saying yes. Okay, let us think out why we can actually start from I into I. So let's say I pick up j equals to some x into I, and I say that this x is, oh sorry, and I say that this x, the number x is less than I. So if I start from any prime number x which is less than I, then that with this that just tells me that that particular prime number was already discovered beforehand, right? Like if any prime number x, if I start from any prime number x which is less than I, then I am very sure that the particular x has already been identified. If x is less than I, then this particular x has already been identified in my prime set, right? And if this particular number has already been identified, has already been identified, then for this particular number I have already marked down all its multiples, right? And since for this particular number x I have already marked down its multiple, so maybe I don't have to again redo the entire code from scratch. I can just choosing it is just a waste of operation, since if x is less than I, then we have already marked down all the multiples of x beforehand. So the first optimicity that we can use here is, rather than starting from 2 in ti, it is better if we start from j equals to I into I. Write it down the separate column. So rather than starting from 2 into y, we should start from j I into y, so that we are not losing out, or like we are not going through the same numbers again and again. Okay, so let's see. Okay, the now looking at the same analogy, now here I say that j has started from I into y and j less than n, like j. So since here j is already starting from I square, don't we think that in this particular case, for like let's say in the bigger loop, we are at a particular I which is more than square root of n. So in that case, I star I will be more than n. So in that case, this particular loop will not even get executed, right? Like for any I in this particular loop, if that value, if its value is more than square root of n, then obviously I square, which is this particular value, will be more than n. And if I square is more than n, then this particular loop will not even get executed for that particular number, right? So rather than going so far, even here, we can use this particular terminology like I into y less than n, and our loop will still work fine, because anyways, for the numbers I which were more than square root of n, we will not having this particular loop going. So this is the second optimicity that we can use, is that we can also kind of lower down this I less than equal to n up till I into y less than equals to n. So like this is the very we can say the efficient way of doing our sieve. Okay, now let me just briefly go through what is the expected time complexity of our particular sieve algorithm, and from that we will try to figure out what can be the maximum value of n that we can use here. Okay, just give me a second. Okay, now let's say for if the value of I is 2, then my second loop, let's say my n value of n is 10, and when my I the value of I is 2, okay, I is marked and I have put I in the prime set, then I will iterate over with the numbers 4, 6, 8 and 10, right? So basically if I what I am able to see that for I equals to 2, the total number of operations that my second loop will go through is nothing but n by 2, like considering n equals to 10 here. So if when n equals to 10, the moment I see that I equals to 2 is in mark, so firstly I put 2 in my mark set, then for 2 I reiterate through its multiples and mark them as mark. So in that case, I'm able to see that my second loop, I'm talking about my second loop, for my second loop, it has gone, the number of operations that had undergone in my second loop are n by 2. Similarly, using this particular analogy, we can actually see that for any number I, the number of operations that happen in the second loop is about n by I. Okay, so we have got this idea that okay, n by I. Okay, now there is a harmonic progression which is 1 plus 1 by 2 plus 1 by 3 up till 1 by n. So the value for this particular summation is log 2 of n. Okay, the value is log 2 of n. Now let me look at my uh, number of operations that I'm going through my loops. So in that case, it should be nothing but n into 1 by 2 plus 1 by 3 plus dot 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 1 by x. So where every denominator is a prime number. Now you can see that, okay, if I say 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up till a particular 1 by n, and then if I say 1 by 2 plus 1 by 3 plus 1 by 5 up till a particular, let's say, n only, and here all the denominators are prime, so the summation of the top part is more, right? So this particular thing is greater than this, right? And the time complexity of this particular thing was log 2 of n. So eventually the time complexity of our C function comes out to be around n log 2 of n. So like this is the time complexity of our C function that we have just created above. Like if you want a very detailed mathematical proof of why it is coming around this particular evaluation, you can look at CP algorithms or any other website. But I just gave you a overall understanding of how the time complexity of Sieve is kind of being figured out. So now let's, as some of you has already asked, what can be the maximum value of n that we can compute? So if I take n equals to 10 to the power 7, like the moment, like n equals to 10 to the power 7, I wasn't able to take in my previous, like the normal way in which we were doing like the n root n strategy. Now let's try taking n equals to 10 to the power 7 here. So if n equals to 10 to the power 7, then this particular figure will come out to be 10 to the power 7 into log 2, log 2 of 10 to the power 7, which will be around 10 to the power 7 log 2 7 log 2 10. And if you try to figure out what this particular number will be, so I guess it will come something around x into 10 to the power 7, where x will be less than 10. X will be less than 10. Like you can do this computation, log 2 of 7 into log 2 of 10. So it will, so by looking here, we can say that the total number of operations is gonna be less than 10 to the power 7. Sorry, less than 10 to the power 8. So using our Sieve uh, algorithm, we are able to compute prime numbers in a range from 1 up to 10 to the power 7. Whereas in our earlier case, we were only able to figure out prime numbers in a range of 1 to 10 to the power 5. So this is like there's a two magnitude of like there's a, like from 10 to the power 7 now, from 10 to the power 5 we are now figuring out numbers up to the range of 10 to the power 7. So this is a huge advantage that we get when we use Sieve. Okay. Does like any questions you can post on the chat?
There is some technical glitch. Evan is joining us soon. Hey Ivan, thanks for the session. So,
Yeah, like sorry, I just got disconnected for some time. I was just going through the questionnaire.
yeah, okay. Give us a time. I will introduce the student by our competitive programming course.
Okay,
Then we
okay,
can
sure, sure.
start.
Yeah,
Yeah,
yeah, sure.
okay. Thank you.
Do I need to stop my screen sharing?
Yeah, you can.
Okay, sure.
So, if you have any query regarding this course, you can post your query here, which is visible in chat box. So you can fill this form for your query. So our team will get back to you. Okay, guys. So you can confirm in chat box. Am I audible? My screen is visible clearly. Or if you are like to enroll in this course, so there is our course link. You can click here, and there is one coupon code that's a start CP20 to get off of 20%. So you can apply this code to enroll in this course. So this is our course page, and there is a syllabus which we will cover in upcoming 10 weeks. And Ivan will be the mentor of this batch. So today he covered the important topic which already given in the second week of this course. So if you have any query, you can ask here. We will answer. And let me now pick up your doubts. So even there are many doubts which asked by users. So let me pick their doubts one by one. Okay.
Okay, okay, sure.
Yeah. So in starting, there is one candidate asked one doubt. Give me a second. So he's asking about your background, first of all. So this one is his question. How do you transit to coding being an electric engineer?
Uh, like the very basic thing was during my second year, I kind of started figuring out that maybe I should focus towards coding. So what I did was I was more of a self-taught programmer kind of thing. So during my second year, I started DSA and CP parallelly. So doing that was a big help for me since firstly, so those two things kind of went very well for me during my second and third year.
Yeah. Okay. One student also asking competitive coding कब से start करें? So there is a Ravi Mahato who asked this question.
Like if you talk about me, like I kind of started very late. It was during the end of my second year. So there isn't any particular fixed time because like the thing is if you want to start CP, you need to at least devote 2 to 3 months properly towards it. Then only you can see some outcomes, because if you just join in and if you try doing it for around 10 days, 11 days, or maybe a month, then you may think that okay, it's not so fruitful, so you may just leave it. So it doesn't depend, you may start after your sixth semester also. Just the thing is that if you are entering the domain of CP, at least you need to give 3 months so that you can see some end results. Otherwise it will be just a waste of time on your end.
Okay. There is one person, Chris Mahajani. He is asking ki, could you please give me him some tips how he become a 5 star in CodeSep?
Like firstly, I will just say that like don't just think about the ratings, the 5 star or a 6 star. Like these are just rating on paper. Eventually the thing is whether you are able to solve the problems or not. Like there may be like so if you ask if you are asking tips, then there aren't any specific tips of becoming any star on any website. So the thing is that if you continue doing problem solving, then eventually your skills will improve. Like
Yeah.
don't
So
focus too much on any star or something like that.
I hope continuity is the best key for this thing. So if you continue practice, you will become a great coder one day.
Yeah, yeah, like stars and all like are secondary things.
Yeah, okay. There is one other question. How many year of professional experience required to the position SD at Google?
I mean, it depends, right? There are different engineers: software engineer 1, software engineer 2, software engineer 3, and then senior engineers. Like everyone, for everyone there is a separate requirement, so you can see through yourself like in which position you fit in.
Yeah. Okay. So there is next question. Can I do CP in Python?
I mean, it is again very like it is again very relative. Like if someone is very confident in doing in Python only, then okay, he may try. But if, like again, the things like if we look at the majority, like majority people prefer C++, then Java, then maybe Python. So it depends on the user only. Like if that particular person is very confident that he can write the most efficient algorithms in Python only, then maybe he can continue.
Okay. There is one candidate reservoir who is asking CP course of GFG can crack the SDA interview of Google and Amazon. So
Like
how
again,
much it's helpful for them?
like again it becomes relative only, because in a way, like if you are going through the course, then you will understand the topics, you will understand how to solve problems. But eventually if you want to crack any company, you have to again go and solve problems, right? So like understanding the topic is a different thing. Maybe if you join in the course, you will get in touch of a lot of topics that will be helpful in developing your understanding. But again, at the end of the day, you need to also go and do some problems, whether the problems that may be listed in the course only. Like when we do the course, we also have a practice sheet. So maybe doing the practice sheet or any other question, like again, like you need to do problem solving, like understanding the topic and then problem solving. This should go parallelly.
Okay, there is one question someone asking about that which language is good for competitive programming, Python, C or Java? What is your
Um,
view?
like I haven't seen many people using C, because in C you need to create your own structures. So as per I like what I have seen is that mostly people prefer C++. Then I have seen some people doing in Java, then some in Python.
Yeah, okay. So could you explain in detail, because you have a previous experience of CP course, so how it helpful for the audience if they enroll in your course?
Uh, I was like I think I also taught this particular course last year during the month of October, November.
Yeah, correct.
Yeah, like during the course, the constant feedback that I was getting was like everyday people were getting to learn about topics that they've previously feared a lot. And after the sessions, kind of they got the confidence to kind of uh, try to learn the topic and also try some problems related to them also. So maybe it might impact the problem solving, like once the fear gets reduced, one has the courage to solve problems, like, and problem solving is the most important thing. So yeah.
Yeah, I hope everyone doubt has been clear from the chat box also. If you still have any doubt, you can post your doubt in the joint form, so our team will connect you later. And if you are like to enroll in this course, so link is given in description plus with coupon code, so you can apply that coupon code with you will get a 20% discount. So do companies allow Python in all coding round? Yes, Rohit. I hope so. Correct, Ivan? There is one last question.
It again depends on the companies. I have heard few companies may not allow Python in their coding rounds, but like it again depends on the company. Like you have to see through yourself.
Yeah, okay. So now everyone doubt has been catered till now. So thanks, Ivan, to give us such
Yeah,
information. Yeah,
yeah, and
okay.
thanks
So
to the audience who stayed to
yeah,
see.
yeah, okay. Thanks everyone.
Yeah, thanks a lot. Have a
Yeah,
good day,
bye.
everyone.
Have a good day.